Hello students, today we're going to look at section 3.2 and that is zeros of linear functions. Now in the last video we looked at linear or graphs of linear equations. So we looked at linear equations. Today we're going to look at linear functions. Now a linear function is a function for which the graph is a line. Wait, if you looked yesterday, a linear equation is an equation for which the graph is a line. So are linear function and linear equation the same? Yeah, they're exactly the same. They just write it in function notation. And you'll remember function notation from earlier this year. Function notation, if this is what an equation looks like, then to write it in function notation, you just replace the y with the f of x. And then you get the f of x is 3x plus 9. So if my equation is y equals 3x plus 9, the function of that would be f of x equals 3x plus 9. So I'm going to give you a second to write this down, and then we'll talk a little bit more about what that means. Oh, I guess you could just push the pause button, so I don't need to wait. Hello. Okay, so we have that the linear function is written like this. And so one of the other things that we need to know is the parent function. Okay? The parent function for linear functions is the function that all of the other linear functions are based around. Okay? And that parent function is the f of x equals x. And if we wrote that as a linear equation, just so you can kind of see it a little in your mind a little bit, we could write it as y equals x. Okay? So if you imagine, if you just draw a simple coordinate plane, if I have the f of x equals x, or y equals x, if x equals 0, then the f of x also equals 0. So that'd be my first point. If x is 1, then the f of x equals 1, so I'd go to 1, 1. And then if x is 2, then the f of x equals 2, and so I'd go to 2, 2. And let's go negative. If x is negative 1, then the f of x is also negative 1. So you see I'm just drawing, and I'm going to do a dashed line so you can see the dots. That would be the graph of the parent function. Okay? It goes through the origin, and it cuts each quadrant basically into 45-degree angles. Okay? Slices right through quadrant 1 and quadrant 3. That's the parent function. We won't spend a lot of time on parent functions right now, but we will spend a lot of time on parent functions when we start comparing functions to each other. So if we look at the zero of a function, which is the whole topic today, if we look at a zero of a function, the definition of the zero of a function is the value of x for which f of x equals 0. So basically to find the zero of a function, I replace the f of x with 0 and then solve the equation. So in that first example that you have in your notes already, that is the f of x equals 3x plus 9. If I want to find the zero of that function, then I just replace the f of x with 0. And so I put 0 equals 3x plus 9, and I solve the equation. Well, you know I have to subtract 9 from both sides. And so I get negative 9 equals 3x. I divide both sides by 3, and I get x equals negative 3. So the zero of this function is negative 3. Again, I just take the f of x, which is essentially the y, and when it's in y equals, or f of x equals, then I can substitute that for 0, solve the equation, and I get x equals negative 3. So negative 3 is the zero of this function. Now let's see if we can just put some pieces together, okay? So we just figured out that the zero of this function is negative 3, x equals negative 3. And we used 0 to substitute for the f of x. And the f of x is the same thing as y. So essentially I could say that y equals 0. So if y equals 0 and x equals negative 3, what is another word that we can say for x equals negative 3? it's the zero of the function, but it is also the x-intercept. Exactly. Okay? So here's something to connect. The zero of a function is exactly the same thing as the x-intercept. But we call it a zero of a function, fancy words. I can tell now that there's a glare on the camera, and so this says the zero of a function equals the x-intercept. The x-intercept and the zero of a function are exactly the same thing. But wait, there's more. Because there are actually a couple other names for this exact same thing. Okay? So we can call it a zero of a function, we can call it the x-intercept, but it's also called the root. Okay? It's the root. Why do they call it a root? Because it's a solution. Oh, there's another word. It is also the solution. So I could say that x equals negative 3 is 4 different things that are all the same. It's the solution to the equation. It's also the root of the equation, and I'll show you why in just a second. It's a zero of a function, which is also the x-intercept. All 4 of those things are exactly the same. Okay? Ooh, that's like a dance move. Ooh, but we won't. So it's too early in the morning for that. So know that all 4 of those are the same thing. If you see one, it means exactly the same thing. So let's go over here to a graph, and let's graph the x-intercept, which we said is negative 3. So I'm going to do 1, 2, 3, and we're going to pretend it's right there. That's the root of my function. It's the root because that's where it crosses the x-axis. The root is also the solution, which is where it crosses the x-axis. Okay? It's also the zero of a function because that's where it crosses the x-axis, where y equals 0. And it's also the x-intercept because that's where it crosses the x-axis. So all of those things make it the root or the solution or the zero of the function, which is also the x-intercept. So now let's see if we can find the zero of the function from a graph. Okay? So I have example number 1 here, and you don't really have to be accurate on these things at all. Just draw an x-axis, a y-axis, and draw a line with some little tick marks, you're good. Okay? The zero of the function on this one. What did we say the zero of the function was? I'm sure you're saying all of these things at the same time. It's the root, solution, x-intercept, and the zero of the function. Okay, great. So it is where the line crosses the x-axis. So where does the line cross the x-axis? Exactly. X equals 2. That's the solution, the root, the zero, and the other one. So over here we have graph number 2, and I'm using the blue line. Okay? What is the zero of the function of the blue line? Does it cross the x-axis? No. Will it ever cross the x-axis? No. Never will. So what's the zero of the function? I think I'm hearing it. No solution. There is no zero of a function. So in this case, there's no zero of the function. Zero of the function is the same thing as a solution. No solution. Same as the x-intercept, there's no x-intercept for this line because it is a horizontal line, and a horizontal line, unless it's the x-axis, will never cross the x-axis. So let's look at a problem here that we might find in our world today. Oh, that was those. M equals 20 minus 0.5 r. Now what's going on here is, you know, the Heart of Texas Fair and Rodeo is coming up. And this doesn't match with us because the prices are way different than this. But, you know, the last time I went to the fair, way a long time ago in Mississippi, carnival rides were 50 cents each. I could ride as many as I wanted to for 50 cents. It's fantastic. My mama gave me $20. Okay? So I need to know how many rides I can ride. When am I going to run out of money? After what ride am I going to run out of money? So I've got an equation. M equals 20 minus 0.5 r. The $20 is the money that my mama gave me to go to the fair. The 0.5 r means each ride, r, was 50 cents. Okay? After how many rides am I going to run out of money? So I need to find the zero of this function, because the zero of this function would tell me when I have 0 money left. Okay? So, plug in the 0. And now what? That green marker does not show up. Okay, so 0 equals 20 minus 0.5 r. Now what do I have to do to both sides? Subtract 20. Negative 20 equals 0.5r. Divide both sides by 0.5. By negative 0.5. I left off my negative. Shame on me, because you shouldn't do the same thing either. That negative has to carry down to the negative 0.5r. So negative 20 divided by negative 0.5r is 40. So this is telling me that I could have ridden 40 rides before I ran out of money. So let's look at this on a graph. Okay, we got a graph, and I'm going to count by fives. 5, 10, 15, 20, 25, 30, 35, 40, and then 5, 10, 15, 20, 25. Okay, so let's start. How much money did my mama give me? We're going to go over here, amount of money and number of rides. How much money did my mama give me? My mama gave me $20. So this is where I started at the fair. Now, do you think my slope's going to be positive or negative? It's going to be negative because I'm spending money, okay? Where am I going to end up? Where's the zero of the function? You're exactly right. The zero of the function is at 40. 5, 10, 15, 20, 25, 30, 35, 40. And so this would be what happens to my money while I'm at the fair. I continue to decrease, continue to spend money, so it runs out. So the y-intercept in this case is my beginning amount. That's good to know because that's always the case in a real world problem. I'll say that louder, that was a whisper. It's always the case in a real world problem that the y-intercept is always where you start. The zero of the function, or the x-intercept, or the solution, or the root, is where it ends. When I ran out of money. I ran out of money at 40 rides. That is my x-intercept, or my root, or the zero of the function. So I can tell if I looked at any point after 20 rides, how much money did I have? I don't know because I can't really look on the graph, but I could figure out graphically. $10. Okay, so that's what the interpretation of that zero of the function is. That is when I ran out of whatever it is I started with. So tonight you have 3 practice problems, just 3. And they are find the zero of each of the functions. The first one is written in function notation. F of x equals 5x minus 30. The second function is written in an equation form. 3 minus 6x equals y. Ooh, mix it up a little bit. And number 3 is graphically. Find the zero of the function. Find the zero of all 3 functions. Take a picture of your practice problems and the work associated with them and submit it through Edmodo.